Okay, so we have looked at limits from tables, limits from graphs, limits algebraically, and now we're going to go in a little bit more in depth into infinite limits versus limits at infinity. So let's talk about the difference between those two. So infinite limits, when we say that, what we mean is we have a limit as x approaches some number, and that's an actual number, of our function. Infinite limits means that as we approach that x value, our graph approaches either positive or negative infinity. Let's look at that. So f of x is this graph. This is g of x. As x approaches 2 from the left of f of x, so here's f of x, as we approach the x value of 2 from the left, my graph goes down, 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 down. It goes to negative infinity. If I approach it from the right, I'm going to positive infinity. And what is happening at 2? Well, that means there is a vertical asymptote. Let's look at the other one. So g of x as x approaches negative 1 from the left. So here's g of x. As we approach x value of negative 1 from the left side, so I'm going in this way, my graph goes, and then it goes down, 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 down. It's going to negative infinity again. As we approach negative 1 from the right side, so I'm coming in with my pen this way, it goes shooting up. It goes to positive infinity. And again, I have a vertical asymptote at that x value. Now, the difference between an infinite limit, that just means it equals infinity, limits at infinity means I'm finding the limit as x approaches positive or negative infinity. Now, this could equal a lot of things. But what it's really telling me about, so when x is approaching negative infinity, we're looking at this side of the graph, and x is approaching positive infinity, I'm looking way out this way. This is really just giving me my end behavior. And sometimes we've talked about end behavior, looking at the left side of the graph, looking at the right side of the graph. So this is, if I'm talking about x going to positive infinity, I'm talking about the right side of the graph. Where is it going? Well, if I'm looking at f of x, the right side of the graph isn't going to go all the way down to negative infinity. It's leveling off. It's leveling off at this y value of 2. At the other side, going to negative infinity, that's the left side of the graph, it's also going to 2. What this means, if both sides are going to the same y value, this means I have a horizontal asymptote. Now let's look at g of x. G of x, as x approaches positive infinity, I'm looking at the right side of the graph. Now on the right side of the graph, this is going in an upward trajectory, so it's going to keep going up and up and up and up and up. It's going to positive infinity. If I go the other direction, as x gets more and more negative, my graph is going down, 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 down. It's going all the way to negative infinity. All right. Now, we must develop an analytical procedure by which we can figure these out. So if we were doing it just algebraically, how could we do this? Well, if we're thinking about end behavior, when I look at this function, what affects the x the most? Well, it wouldn't be the constant. That just moves it up and down. It wouldn't be this. It's really just this first term, or leading term. So if I plugged in, and I hate to say it, plugged in infinity, if I cube infinity, it's still infinity, times negative 3 means this is approaching negative infinity. So it's negative, that means it's going to be going down, and that's infinity. Now this one, I could multiply it all out to find that leading term, or think about what's most important in each of these. So the most important thing in that parentheses is the negative x, and it's being squared. The most important thing in here is x. The most important thing in here is x. So I'm going to multiply those together, and that would be what my leading term is if I multiplied everything out. So negative x squared makes it positive x squared times x times x. This would be x to the fourth. Now, if I plug in negative infinity, a negative number, no matter how big, to the fourth power is going to end up being positive. So this graph is approaching positive infinity. Now let's look at this one. What is the most important part in the numerator and the most important part in the denominator? Well, it's really going to be the term with the biggest exponent, which in this case is just our x's. So I have negative 2x divided by x. I get negative 2. Now, this is really, when we have a fraction, we're really just dividing. And so let's think about what happens when we have the denominator bigger. So 3 over x. What is happening as x approaches positive infinity and negative infinity? Well, on this one, going this way or going this way, it approaches the same thing. The limit approaches 0. On this one, if I look at the left side or the right side, it also approaches 0. So if the denominator is a power of x, power of x, and the numerator is smaller, well, especially if it's just a number, we are going to be approaching 0 every time. So the denominator bigger, it's going to approach 0. Now let's look at these examples. So I've got, as x approaches infinity, of x plus 2 over x squared plus 5x plus 6. So what I like to do is just narrow it down. This is going to be the same as looking at the limit as x approaches infinity of x over x squared, which would be the same as 1 over x. Which means it approaches 0. The denominator has a bigger degree. If we look at the next one, the most important parts are going to be the 2x squared and the x squared. I can ignore everything else and just look at the largest terms, the largest exponents in the numerator and denominator. And if I divide that, I just get 2. And if we look at the graph, we have a horizontal asymptote at 2. All right, now let's look at this next one. Okay, this one, the numerator is bigger. So let's just narrow it down. If I narrow it down to the terms that have the largest exponents, I get x squared over x. So this would be the same as the limit as x approaches infinity of x. Well, if I plug in infinity, I'm just going to get infinity. Let's see if that works. As x approaches positive infinity, that means the right side of the graph, my graph is going up, 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 up. It's going to positive infinity. So in the next examples, let's see what happens if we approach negative infinity. So on this one, does it matter if I'm approaching negative infinity? Well, I still have 2x squared divided by x squared. It still approaches 2. The one it's going to make a difference on is this function. as x approaches negative infinity, if I divide those leading terms, x squared divided by x, I get x. If I plug in negative infinity for x, I'm going to get negative infinity. The left side of the graph is going down. Now, going to negative infinity does not make a difference when it's a horizontal asymptote. It only makes a difference when we have a slant asymptote, or the graph is a polynomial of some kind. Now, let's see if you can do these just thinking about what's left. So I'm going to give it a pause. Negative 2x squared divided by 3x squared is negative 2/3. It doesn't matter what x is. So we're approaching negative 2/3. I have a horizontal asymptote. Ooh, okay, let's look at this one. 2x squared divided by negative x would be negative 2x. What happens if I plug in negative infinity? Negative times a negative makes this positive. I forgot an example that you might need for 1, 2, and 3 on the practice. And this is when we have an asymptote. So let's see what happens here. If I factor out, I get x minus 3 and x minus 1. In the denominator, I get x plus 3, x minus 1. So these would cancel out. But what's happening actually, I messed that up. This should have been a plus. I'm so sorry. Oh, gosh. Okay. I was like, why is this? That shouldn't have been the whole. X plus 3, x plus 1, x plus 3, x minus 1. Okay. This is what I was looking for. When 1 is not the whole, it's where the vertical asymptote will be. So we're looking at the limit as x approaches 1 of x plus 1 over x minus 1. I cannot plug in 1 or I get undefined. But what I can plug in is a number really close. So let's pick a number really close to 1 from the left side because it says negative. So 0.9. I'm going to plug that in. So 0.9 plus 1 over 0.9 minus 1. And all I care about, because I know this is an asymptote, it's either going to go to positive infinity or negative infinity. I want to know if what I'm getting is going to be positive or negative. Well, the numerator would be positive. The denominator would be negative. Positive divided by negative is negative. This is going to approach negative infinity. What about this one? Okay, so limit as x approaches 2 from the right. I'm going to change this one too, where it doesn't factor. Oh, whoa. Okay, so from the right, that'd be 2.1. It's really close. So let's let x be 2.1. 2.1 squared plus 4 over 2.1 minus 2. That would be positive, positive, positive. That means my graph is approaching positive infinity. So those would help with 1, 2, and 3, or you could look at the graph too, or you could make a table. Any of those options would work.